Hi, it's Tony Verhoeven with the National Air Filtration Association. Recently, NAFA conducted a webinar where we assembled NAFA member panelists who answered questions on air purifiers, bipolar ionization, and UVC as part of a total package solution with traditional air filtration. Panelists included Keith Jordan from Sanuvox, Jose Senatore from AAF Flanders, and Brad Sharp from Velocity Building Technical Services. They were moderated by Jeff Gradek from Filter Services, Inc. This is one where you'll definitely enjoy the audio, the conversation, the banter. However, the slides are going to be very, very useful. So you can find those in the link in the description of this podcast. You can also subscribe to YouTube and rewatch the webinar over there, and you can download the slides. Or you can go to our website, and that is at nafahq.org. Look for the COVID-19 menu item and look for COVID-19 cleaning trends. And also, by the way, we have a ton of other webinars that you may want to watch or listen to as well. Thanks so much. Subscribe to the podcast, subscribe to our YouTube channel, and please reach out to us if you have any questions. You can find us at nafahq.org. Enjoy.
The format today is going to be each of our panelists, Keith and Jose and Brad, are going to give us a couple-minute presentation on their marketplaces and technologies, and then we're going to have an opportunity to go through some questions and answers and continue to learn from them. Also, Keith and Jose and Brad, I wanted to thank each of you for your time. I'm excited to learn from each of you today and better understand your markets. All of us at NAFA appreciate the training you're providing us, and if there's any way any of us can return that favor to you, whether it's maybe a presentation in your marketplace or your companies, please let us know. We're indebted to you for the training. And before we get started, I want to take another second and talk about NAFA's mission statement. NAFA's mission statement reads, to be the global source for expertise, education, and best practices in air filtration. I'll read that again. To be the global source of expertise, education, and best practices in air filtration. Today's a great example of how NAFA is fulfilling that mission by educating us on these adjacent technologies to our marketplace and how they affect indoor air quality. It's important to note that each of these panelists, Keith, Jose, and Brad, they're passionate about their fields. And as we listen and learn from this panel discussion, we as NAFA members have to understand that this is not a commercial for their products, and if their passion comes through, it's because they're successful industry experts and successful people in their own right, and they believe in their products. So to be clear, NAFA does not promote or endorse these products, but it is our job as filtration experts. It's NAFA fulfilling its mission to educate us, and it's our job as filter experts to understand these technologies and take back what we learn to our companies and our markets and translate it as we see fit. So having said that, let's jump into the program. And I think the first slide presenter is Keith. Take it away, Keith.
All right, fantastic. Thanks. Welcome, everyone. I'm first up. We got 10 minutes per person, so I've got about 6 slides I'm going to cover pretty quickly. If you have additional questions, feel free to put them in the chat box or send us an email or send NAF an email after. Next slide, please. Now, I work for Sanuvox Technologies. We've been doing this for 25 years, specializing in UVC, air, surface, and odor disinfection. And our co-owner is a PhD in nuclear physics. So he makes sure that we pay attention to industry guidelines and what the top brains in our industry is doing, because they have the most research, they've got the most experience and application. So ASHRAE, CDC, WHO, IES, which is Illuminating Engineering Society, IUVA, International Ultraviolet Association, NAFA, I regard as one of the top industry guideline organizations, and then Harvard has some of the top medical researchers in the business. And all of these top organizations have UVG as one of their top 5 recommendations for microorganism and aerosol disinfection. Now, why is that? Well, because UVC and UVGI has been used for over 100 years. Top peer-reviewed technology. Several medical research studies have been proven to show the efficacy and the safety of use with UVC or UVGI. So what I'm going to cover here, the next 5 slides, are just the top UVC, UVGI, GUV applications that you're going to run into in the marketplace right now. And I put those 3 terms in there because they're interchangeable at this point. UVC, UVGI, GUV, all relatively mean the same thing. We're going to combine those. We just haven't got there yet. So we're going to talk about airstream disinfection, evaporator coil cleaning, surface disinfection, upper air UV, portable or standalone air cleaners. So next slide, please. All right, this has been on everybody's wish list for the past 11 months, using UVC for airstream disinfection. There are 2 methods to using UVC. You can do, on the left, parallel installation to airflow, or on the right, perpendicular lamps to airflow for air disinfection. Now, both methods will work, will achieve your desired air disinfection, whether it be SARS-CoV-2, influenza A, influenza B, TB, anthrax, whatever it is. Both will work and achieve the necessary disinfection on a per pass or recirculation basis, but they have to be sized correctly. Things we look for: CFM, how fast is that air moving past these lamps? Duct dimensions, is it a large duct, it is a small duct? What's the reflective, or what type of material is a duct made of? Aluminum is higher reflectivity than stainless steel, or internal insulation has no reflection. Then what's the contaminant? As I mentioned before, each contaminant is susceptible to disinfection at different doses. So we need to know that. We also need to know the temperature in the duct and potential humidity issues. Is there a humidifier upstream of these? So, also, and the end of a lamp life. So we know the output of UVC degrades over time. So when you're looking to use these properly, make sure that your sizing that you get from the manufacturer sizes at the end of lamp life, be it 1 year or 2 years, because you want to make sure that you have that minimum necessary disinfection throughout the life of these systems. Now, one caveat to perpendicular over parallel is airflow and temperature of air. So airflow, these lamps are going to get hit directly with particles or particulates. You may have to clean them more frequently to make sure that you have the necessary UV output. Air temperature, air hitting lamps perpendicular to the airstream have a tendency to cool down, which will affect the output of the UVC. So just be aware, both of these will work. Just make sure that you get them sized properly. So next slide, please. All right, this is the workhorse of the UV industry. Prior to the pandemic, this was first and foremost probably everybody's top selling product, and it is very simple. It's for a non-chemical or chemical-free, residue-free cleaning of an evaporator coil, making sure there's no biofilm growing through the fins of those coils, restores efficiency, make sure you get optimum heat-cool transfer, and extends the life of that coil. It can reverse clean a dirty coil, or it can keep a clean coil clean. This will still be one of the top 2 applications moving forward for the UV industry. So next slide, please. All right, this industry is about 7 to 8 years old, and it came from the hospital using UVC in either systems that you physically roll in, or now we have robots that will go from room to room, and if there's nobody in there, it'll turn itself on for a desired disinfection time period. Now, what these are designed to do is offer a secondary method of cleaning after your physical wipe down, to hit the high touch areas of before it was C. diff and it was MRSA in hospital settings, but now they've expanded these uses to hotels, schools, office buildings, conference rooms, again, as a secondary method of disinfection. You do not want to use these as your primary method or primary and only method of disinfection, but this is gaining popularity and probably will be a standard moving forward. Next slide, please. All right, now we have upper air UVGI. Now this is designed for more of a spot treatment. If you don't want to put the UV into the return or supply duct or in the air handler, you take these systems and you place them 7 feet or higher in a room. What it does is it shoots the UVC across the upper parts of the room. So as natural convection or air movement, if you have any infectious aerosols, as they float up into the UV zone, they get disinfected. It's a very, very useful method for spot treating in high population areas. The one caveat is you have to look for if the UVC will damage the paints or plastics on the ceiling, or if you have reflection off of signs or computer monitors. You have to monitor the occupied space at our eye level for any of those reflection and dose, irradiant dose or erratic dose, just to make sure that humans are not exposed to this. But this is an excellent method for spot treatment outside of using the UV into HVAC systems. Next slide, please. And then an alternative to the upper air UVGI are standalone or portable air cleaners. And typically these will have the UVC enclosed inside of a chamber, so you have no UVC exposure to occupants. You have no risk of that. And a lot of these will pair high efficiency filtration with them, higher than MERV 13, MERV 15, and HEPA, because they'll have a fan with them that can power the air and recirculate the air inside of that room that you're trying to treat. Whereas the RTUs or the air handlers may not be able to go above MERV 13 because of pressure drop. These are an excellent method to get higher MERV efficiency and better spot treatment in rooms. And Jose is going to talk a little bit more in detail about these. So that concludes my 5 slides. Thank you for your attention, and we'll move on to Jose.
Hello, everyone. Thank you for the opportunity to talk in here, and I hope I can collaborate with you guys and the NAFA. My topic is not so sexy as UV or other new technologies, but I will try to do my best here. So can you move next slide? So basically, mechanical filtration is a well-recognized technology. It has been in here almost 100 years. So this is nothing new, but the application now is, I would say, more used in the indoor air space. So, but I want to highlight some topics about the mechanical filtration. One is the filter. An air filter is always on. So I used to say that the filter is democratic because he filters the particles, viables or not viables particles. So doesn't matter what is reaching the filter, but the filter, if designed well, it will filter the particle. If it's a virus, a bacteria, or if it's just a dust, it doesn't matter. So right now, talking about air purifiers, basically we have 2 different styles, right? One is the fixed style. Sometimes it's concealed over the ceiling, and the goal is here is try to pressurize the indoor space, or acting like a buster, or recirculating the internal air. And also we have the portable units. These units are installed inside the room, and we recommend to install these units close to the contamination source. So we have in this picture these 2 examples. Next slide, please. So basically, the traditional air purifier has an UPRI filter and also an HEPA filter. Of course, there are many different styles and many different filter efficiencies applied to these products. But we recommend especially for the virus filtration, and also especially during this pandemic, the usage of HEPA filter, and as we call as true HEPA filter. So a real HEPA filter is tested according IST standards, or sometimes according to European standards, or even ISO standards. So these standards are, ensure that the filter is leak-free, and it has the minimum efficiency along the whole filter's life. So this is very important. So we need to ensure that the filter will have a minimum efficiency, whatever is the particle size. So also there are some additions to this product. Sometimes we have an UV close to the filter. We have an ionizer. These new technologies are getting embedded to the air portable units. So again, the air filter can be used with in conjunction with these new technologies. So to complement and to improve the final result for the end user. But I just want to highlight that, especially for UV, it's important when the UV installed close to the filter, it's important to actually to check the UV power, because sometimes this high power can affect the filter material. So it's important to check how close to the filter is this UV light and the UV power output. Next slide, please. So for the portable units, the main challenge is to define how many units we need to use in some space, and another point is the noise level, right? So since these units are installed close to the user, especially in a school, for example, the noise level is a very important piece of this equation. So it's important to check if the noise level is okay for that particular population, and also to avoid this problem, to reduce this problem, it's recommended that the portable unit has the contamination cycle. So when there is no one in that space, you can run the system in a higher speed to flush the contamination. Then you can reduce the speed and of course the noise when the person is close to the equipment. We have also, we are developing some standards for this product. So far, we just have one standard in US, not for commercial product, more related to residential, but ISO is working on a test standard as well. So this is very important for this product because it's difficult to design without any standard. Next, please. So because of these challenges, it's very important to take the ventilation effectiveness into this account, because the portable unit can have a different how can I say, can have a different result depending on the size of the room and depending of the furniture and the position of that specific portable unit inside that room. And this can compromise the ventilation effectiveness. So if you install this portable unit close to a returning air or close to a big furniture or something else, the ventilation effectiveness will be low, and then you are not using the benefit of this technology. So a selection software can help, and also CFD simulation can help as well to define where is the best spot to place this air purifier and what is the airflow rate needed for that specific installation. And also I want to highlight that sensor technology right now can help to define where is the best spot to install the unit, and also to monitor the indoor air quality. And right now, the sensor technology is spreading around, and the cost is reducing a lot. So embedded sensor to this product will help the user to have a clean view of the result of that specific product and a specific technology. Yeah, I think this is, next slide. I think this is what I have for you guys as a starting point. So go ahead, Brad.
Jose. Yeah, go ahead, Brad. Mute, Brad.
That should be better. You got me, Jeff?
Yeah.
So yeah, thank you very much for having me today. I'm very proud to be a NAFA member, very proud to be part of the organization and contributing today. And I'm glad to see the membership's interested in what I'm involved in. I come from, I didn't go through the traditional ways of getting into the trades. I came up through the United States Air Force and on the nuclear weapons side. So my training's a little bit unorthodox and my approaches are a little bit different to solving problems, and it's been very good for our business. But I think now is a great time to have that background. And what the other two gentlemen, Keith and Jose, have been talking about is awesome, because the way they're talking about things and the way they're looking at this, if we take air filtration fundamentally as our primary concern for returning back to normal after COVID here, and we look at these other options on how to improve that, then we can stop some of the almost insanity among the building engineers, owners, and managers about, well, how can we maintain all this outside air? How are we going to get enough filters to keep changing them? Well, the answer is pretty simple. You can implement things like UVC, you can implement portable room cleaners, and that can take that load off of that, so you can reduce that outside air and still achieve the same levels of comfort as you had before, but with a much better, safer environment. So anyway, I'm super glad to be part of this panel for that reason. I love that we're doing a layered approach here, and really this is how we're going to solve the problem. This is what we need to be talking about, is these implementing and overlapping our technologies. So next slide. Yeah, so some quick facts, and these are really good, and I'm going to try to be quick about these because, you know, I'm trying to have enough time for questions. But take a look at just this. I don't like reading PowerPoints to people, but it is true. That is not a made-up statistic. By the time you're 80, you will have spent 72 years of your life indoors in some fashion or form, be it in a vehicle or in a building or under some kind of, you know, confined cover. So that is a true number. The indoor air pollution is on average 3 times higher indoors than it is outside. And it is 5% of all cancers are coming from what we're exposed to inside, be it VOCs, you know, just all the different things, the manufactured chemicals that we're exposed to. And both of these technologies, even UVC, can help with the overall IAQ. It doesn't just kill viruses, it also helps with VOCs as well. And a great point here, $7.5 trillion was spent on green buildings over the last 30 years. And they only spent about 400 million on IAQ. I bet you with COVID, they wish those numbers were the other way around now, because $7.5 trillion in COVID hit, and look what happened. All that optimization didn't do much for us. Empty buildings are really efficient, but kind of not. So 40% of all energy consumption, these are all numbers you guys should know. And but the last one is really kind of important, is you will need to think about health dashboards. And we need to start educating our customers and our building owners and even our vendors and competitors and everyone else about the need for understanding how healthy a building is overall. And I'm telling you, the key component to that, the first thing that they're going to look at, if you look at where the code is going, where LEED is going, all the, you know, National Institute of Building Sciences, NEMI, NEMIC, go down the list. WHO, CDC, they're all looking at filtration and airflow and healthy buildings. It all starts with filtration of some kind or some type of technology associated with it. So next slide. Not going to go too much into this, but I want you guys to take a look at that book by Mr. Allen and Mr. McComber. I think it's McComber. The one guy is from the Harvard School of Business. The other guy is from the Harvard School of Public Health. If you don't know this book, you should, because this is the playbook that the federal government's going to be going with. Green buildings are out, optimized healthy buildings are in, which will get me into, we'll start talking about plasma ionization, which I know is what I'm supposed to be speaking to more specifically, but I thought it was important that you guys know a little bit about where the new administration is heading. And regardless, even if they only are here for 4 years, the plan was in place anyway. This was all coming anyway. So this is just timely. PM 2.5, which is particle matter, 2.5 microns or less, matters. That is the new buzzword out there. So if you don't know what's going on with that, obviously NAFA knows a ton about it. They've got over 1,000 position papers that you can review to understand PM 2.5. And then everything about the new normal is going to be environmental, social, and governance for the investing world. So all the new construction, all the new things being built, everything that's going to happen in our country for the next 30 years is going to be governed by these 3 principles. And it's a lot of money going to be going into it. And so you need to know how we're going to be part of that. And the Healthy Buildings book will help you get there. I'm not going to get too much more into it. And normally I talk about it a little bit more and talk about ESG, but take a look at that, Google it and start to understand that the investment in healthy buildings is the future. And so these technologies make a lot of sense. Going forward, the next slide. Yeah, real quick, LEED certifications are going to become federal regulations. There's going to be $46 billion in incentives over the next 12 years. They want to look at more outside air. They want to look at smart glazing. They want to look at nationwide funding mechanism. Co-risk strategies, risk reward strategies are all going to be part of it. And NAFA members should be aware of all of this stuff. Yeah, and definitely a lot of things that have been discounted are now in vogue. So more questions about that, we can talk about it, offline, but this is a great slide just to get you thinking. Next. Yeah, the 9 foundations of a healthy building. You notice that they actually prioritized them in clockwise. So if you want to see the priority of the administrations going forward and where they're going to be putting their money, I'll give you guys just a moment to read the slide and then we'll move on. But take a look. It's not just about air quality anymore. It's going to be about moisture and dust and water quality and noise and lighting. And obviously, you can't run your building 100% outside air all the time. You can't constantly change filters, constantly doing that all the time. It's not cost effective. So these other things are going to have to be implemented to help sustain that. Next slide. Did I lose Tony? Oh, there it goes. This one's important and it affects us quite a bit. The changing work will drive the needs of the building, and Build Back Better being the kind of the buzzword of the day. There is big initiatives out there. Lady Gaga, for God's sakes, is out there, pitching healthy buildings now. We've got Robert De Niro pitching healthy buildings out there. If you guys haven't seen some of the stuff that's going on, the world is paying attention to us. This is our 15 minutes of fame, and we need to grab it and use it to raise awareness. So I challenge all of you to take a look at some of these old and realize the new, and why we need to be moving now towards integrated technologies for healthy buildings, like Keith and Jose were talking about, and myself here more, a little bit about the plasma ion stuff. But take a look at just office space. The old recommended CDC guideline for office space was 100 square foot per person. These were recommendations. The new requirements, we're going from recommendations to requirements, is going to be 250 square foot. Now that's going to pose a lot of challenges for us. So, and then look at the closed office per person for 40 staff. They're looking at 8 to 16 offices, with normal to have 40 staff to have 8 closed offices. Now they're looking at 16 to 24 hours of HVAC running is expected to go from 84 per week to 190. And they're going to be leaning on us to figure out ways to make that affordable and viable and healthy. So we've got some challenges coming. And then of course we've got net zero carbon and all this other stuff coming as well. So it's a great time to be doing what we do. Next slide. This is, take a look where PPE landed on the new CDC approach that just released 9 days ago. This graphic came out from the CDC. take a look at where it's at and think about where you belong on this list and where you're going to be supporting it. I think pretty quickly you realize your importance in the industry. So not much else to say. Let you guys just take a second to look at that. They're definitely going to be leaning on us. They're going to be leaning on us and the technologies we can provide and the solutions we can provide. So engineering, in my opinion, should have been co-equal with elimination, but they had to make the graphic work. So what do you do? Next slide, if you don't mind. All right, the Wells-Riley report. If you guys haven't read the Wells-Riley report, my gosh, I am astonished at how many of my customers have not read the most definitive report ever written about why are we talking about air changes per hour. This report is absolutely definitive, irrefutable. It's the best piece of white paper ever written, in my opinion, and it was out a decade, long before, almost a decade before COVID hit, talking about how does infections, how do infections migrate and what do we do about them? And in that report, they talk extensively about the mitigation techniques that we are going to have to implement. So if you havenent done it, ASHRAE 52.2 guideline and the Wells-Riley report, this report is not written for, it's written for lay people. So download it, highlight it, take it with you, share it with the people that are important to you that are making decisions so they can understand it. It really does explain how pathogen exposure can be reduced to near nothing and why air changes and filtration matter. So next. Oh, laminar flow. Yeah, I should stop on that just for a second. Laminar flow. Laminar flow is the new thing, guys. If you didn't know, we are not supposed to be swirling the air anymore. The new thing is to push the air down and let the thermal climb rise. The reason is dust mitigation, and it lowers the overall load on filters. So if you're wondering why I said now more laminar flow, it's not a pitch word. It's science showing that there are hot spots with this COVID being so small. It likes to stay in certain areas and just spin in the air. Like you could walk through it like a cloud. There's a graphic coming up here in a minute that'll show it. I'll kind of point it out when we get there. Next slide. Looks like I got about 5 minutes left, so I'm going to be buzzing right along. So I apologize for this, so we can get to the questions. But obviously, just take a look at your DDC systems on these facilities you're working on. If you're not comfortable taking a look at them, get your service provider to come in there, get somebody like me or somebody else who's capable, and take a look at where your relative humidity are. Look at your temperatures. Look at what sensors you have that are not working, your DDC programming, and think about updating it if you can, and start getting ready for your healthy dashboard. At bare minimum, it will reduce the burden on guys like Keith and Jose when they come in to help layer these technologies. If you have that information ready for them, it streamlines the process to getting these other technologies and seeing if they're viable. Because not all technologies are viable in all of these different facilities that we work in. I mean, the needs of healthcare are dramatically different than they are in a prison. But in the same respect, they're kind of similar. So we need to be careful about how we spec things. So next slide. Filtering is working. Yeah, if you guys didn't know, the studies are finally coming out. It took a year, but the peer-reviewed white papers are coming out in filtration, regardless of what that looks like, be it UVC filtration, which is a form of filtration, or room ventilators, or plasma ion generators, which we'll talk about briefly here in a minute, last few minutes of my time. Just understand that it all starts with some form of filtration. So, and MERV 13 are still in short supply. And the biggest problem I'm seeing in my world with MERV 13s are people are still not gasketing them. They're not installing them well. They don't have good filter racks. The pressure drops weren't accounted for, and they're getting, cold coils, frozen coils, and things like that. We're still seeing a lot of that. So keep an eye on that. In some of these other technologies, if implemented properly, you can get back to a MERV 11 even in some cases and get the effect of a MERV 13 if you use these supporting technologies. So next. Yep, cleaning. Look at that. I have some germicidal UVC, some FAR stuff in there. Keith's probably jealous. I found a cooler picture than he had. But and then also things like this cordless handheld electrostatic sprayer kit from Ryobi, things like that are working well. The reason people are using these sprayers are like elevators. UVC is really tough to get it to go around corners and below things. It's also tough to cram in a ventilator into an elevator. So sometimes things like this make sense, but they're not your go-to. These things still require manpower, consistency. They're not foolproof, but they do work when implemented properly. Unlike the germicidal UV, which works great, but it's more expensive to get installed. Next slide. This is a little bit just more about UVC. Keith's already covered that, just kind of talks about how it works. And next slide. And here's this is a new kind of technology we're starting to see, which is the prop fans that have UVC built into them. Again, this is something Keith could help you guys understand a little bit more, but you get the general idea from the graphic of what it looks like. These are options for rooms where you don't have other types of ventilation, or a ventilator is too loud. This gives you another option. Next slide. Here we are, finally, and then I'll finish on this topic. I'm sure by now many of you have heard about ionization systems, and I'm going to tell you that I have already put in thousands of them since COVID kicked off. I had a long background with it in the Air Force as part of my nuclear training. We dealt with large concentrations of naturally occurring ions, both naturally and ones that we were generating ourselves with the weapon systems, and so I became very, very steeped in how they work and when it's beneficial to use them and when it's not. I will tell you that there's a lot of things out there that are controversial about them. The initial ones that were not offered to the market a few years ago are good products, but they were not aimed at COVID. And so they're being applied in the way that they were for energy savings and indoor air quality in a general sense, but they're trying to apply that to COVID. And so a lot of what I see out there is sizing is not correct. They're not testing them. So if we go to the next slide, we'll talk about this. So, and I'm not surprised to see that a very prominent man named Mr. Offerman, who is a certified industrial hygienist, put a paper out saying, beware, COVID-19 snake salesmen are here. And he makes a very compelling case for why plasma ion generators are not a good idea. And for those who don't know what I'm talking about with plasma ion generators, basically ions are naturally occurring particles that discharge. They last about 60 seconds and then they discharge. Things like crashing waves and waterfalls, they come through our atmosphere and we can generate them ourselves. And they're highly charged particles, both positive and negative. And if there's something in the air, they'll discharge into it. And so they're very effective at removing dust. And in the case of COVID-19, it will actually extract a hydrogen atom out of the protein shell, cracking it open, exposing the RNA and killing it. The problem is you have to have enough ions for it to be effective. And what I'm seeing a lot of is people are just generically putting these things in and then saying, well, my building's being ionized, it's good to go. That's not the case. And in Mr. Offerman's paper that he wrote, he makes a very compelling case as to why they're not completely effective. And what he did was he made a heck of a case for why like a NAFA professional needs to come in and evaluate the space, evaluate the airflows, take a look at the space and see if no, actually UVC is more appropriate here. No, room ventilators are more appropriate here. No, you need to look at some other filtration options because ion generators aren't appropriate. That's the snake oil side of it. So I would just caution you that before you invest in these technologies, one, know that they do work, they are effective, but also know that they do have their limitations. And next slide, and then I'll wrap it up for questions. All right, so how not to get cheated by ion technology. Don't buy units that produce a lot or try to find ones that are limited on O3. The thing about O3 is that it's one of those unique things. We're talking about, oxygen molecules at their basis form. And they, commonly referred to as ozone. And they, in low concentrations, the human body tolerates them well. A little bit more, not so much, and then eventually they become neutral, and then they become a little bit more caustic, and at their extreme, they can be a carcinogen, cancer-causing, even cause death if the numbers are high enough. Very strange that ozone can go from all the way from good for us to deadly, depending on the concentration. And it's very difficult to control that sometimes. And so some of these plasma ion products do generate large amounts of ozone. I've tested it, I have an ozone tester, I've checked it. Some can produce quite a bit. Nothing that's like mind warping that I'm scared, but it is worth noting, and it is something to think about before you buy. Obviously, installing the units as close to your space of concern as possible is critical. A lot of these folks are trying to jam up in air handlers, But think about it. If they last 60 seconds, and I last 60 seconds, you have 1,000 feet per minute in airflow, and it's going to go 1,000 foot of duct, then no ions are actually going to get to the space because they've already discharged. This is the kinds of problems I'm seeing. NAFA members are calling me up and saying, wait, it's not working. And I'm saying, no, just move the generator closer to the space, get them where in the area of concern, and guess what? The concentrations go up and it works. And we've seen a lot of those kinds of problems. The next thing is air distribution. Obviously, if you didn't start with going up and checking the basic filtration in the first place, you shouldn't be adding these technologies. These are not meant to be remedies. They're meant to be, they add to and overlap and run concurrent with your good filtration that you should have already verified. And then measure the ion concentrations. A good ion counter is about $500. It's not going to break the bank to get yourself some kind of a good ion counter like this one from Alpha Labs that I have in the graphic. So, and if you notice, it measures both positive and negative polarity, just so you know, you add those numbers together. And you want to see for COVID about 7,500 ions per cubic centimeter. That's both positive and negative. In this case, that one's showing negative 17,830 ions. So that would be combined around, it's just short of 40,000 ions, probably when you flipped it to positive. That's a great number, obviously. And that's what you would want to see. That's taking care of that COVID concern in the air. You're near insta-kill in the air and you're under 20 minutes on surfaces. And then install ion monitoring if you want to make sure that if you want to keep your peace of mind. And also just don't, contact people who know how to install it properly. And the results are fantastic. It's future-proof. The units are solid state. They rarely break or go out. They're not very expensive to buy in the first place, but the big problem is it's just not being properly applied out in our world. And hopefully this kind of me doing this kind of a talk to you guys and you guys doing this kind of talk with your customers will keep them from having the problem that Mr. Offerman described in his paper where they got snake oil when they wanted a solution. So on that, I'm open to questions. Next slide. I think there's one more. Oh yeah, this is Washington state law. Go ahead and skip that. Nobody cares about our laws. They're just changing the laws around here. This is some contact information for all of us. I think we're going to leave that up and I'll open it up to questions. Back to you guys.
Wow, thank you, Brad. So, and we do care about you. We do care about you. You're one of our 50 states. Washington matters to us. So crazy time to be in the filtration world. This is, I can't believe the explosion of all the technologies across from filtration to UV to bipolar ionization and et cetera. Thank you for the reference, Brad, on the book, Healthy Buildings. That will be on my purchase list tonight. And we're never going to finish all this stuff. So I'm going to kind of go as fast as we can. I asked the panelists kind of be as quick as you can with these questions. We've got about 15 minutes left. I'm going to start with 2 questions. I actually have 5 questions lined up for everybody. I'm going to start with 2 and see how we do on time, because this could, the way I look at it, could be about a 2-hour presentation. First question I'm going to ask of each of you, and I'm going to go in the order of Keith, Jose, and Brad, is what new challenges and developments do you foresee in 2021 and or in the near future for your marketplace or the marketplace you're talking about today? And how does your product interact and affect with the use of traditional filtration and the future of filtration? It's going to hopefully answer a group of questions. So Keith, if you could talk about what new challenges and developments do you foresee in 2021 in the near future with UV?
Sure, thanks. First and foremost is short-term memory loss. What I mean is I've been doing this to other pandemics, MERS, SARS-1, influenza, bird flu, swine flu, and everybody has a short memory. Once it goes away, everybody goes back to status quo. I'm hoping that this one imprinted enough on everyone's memory that it will last and we'll start implementing proper IAQ moving forward. As far as technology, UVC was still a niche market. So UVC using standard fluorescent lamps are still gaining ground, and we see far UV or 222 nanometer coming in, or LED UVC coming into play in the future. Those costs are still probably 10 times the cost of a standard fluorescent UVC fixture, but they're getting media attention. They're just not commercially available or viable at the time right now, but in the next few years, I hope to see that we can utilize LEDs as much as standard fluorescent lamps. So that's what I see. Thanks.
Thank you, Keith. Jose, what do you see in the near-term developments in your marketplace?
I think for the first time, we talking about portable units, especially, for the first time we have a responsibility to deliver a clean air inside the space, right? So, how can we do that, and how can we design the product to deliver this clean air? So, I see two different complementary technologies to the product itself. One is the sensor. So now we can monitor and we can present the result, and also the software to select the product, right? So we have a CFD opportunity. So now it's not just a matter of adding a filter and adding more air changing rates to the space. It's more related to the benefit of that clean air. So I mean, the idea is, how can we explore better the ventilation effectiveness and also the air distribution? So for the first time, we have this responsibility to present the results to the end user.
Got it. Brad?
I'm seeing something that I'm really pleased to see that I wanted to happen my whole career is I'm seeing a breakdown of walls that used to be there between vendors. You used to see test and balance professionals at odds with controls contractors who are at odds with maybe filter manufacturers. And what I'm seeing is something really great is I'm starting to see everybody come to the table and not try to bash each other's product or capture a market segment, but instead we're trying to figure out how to complement each other's offer. And I think that is a much welcome needed thing. And now, because when we do that, we can present a plan that brings that value proposition. We talked about this earlier offline to these building owners and say, guess what? We can test your airflow. We can verify your spaces. There's places that are underserved. We can put in room ventilators. The places that need UV for the boardroom, we can do that. The ion generators in these other rooms, these offices will work fine. And oh, by the way, we can also fix your ventilation problems. You know, your DDC economization, calibration, and all that stuff used to be territorial, and we would fight. And what I see now is I see the trades and the vendors and the owners working together. So it's the lemon to lemonade thing and I'm with Keith. I just hope it doesn't end. I'm with Keith. The memories are short sometimes. As soon as the pandemic gets a little bit under control, I am fearful that it's going to go back. But right now, I'm going to help lead the charge in interoperability between what we're all doing.
Gotcha. Thank you, Brad. Yeah. Next question is, how does your product interact and affect the use of traditional air filtration and the next phase of air filtration? So just the interaction of your products with what we call traditional air filtration or the future of air filtration. Keith.
Sure, thanks. I'm kind of biased on this because I see UV as the number 2 technology that needs to be implemented next after filtration. So filtration is first and foremost because it captures. UV I view as secondary because it's synergistic. It kills, but it doesn't capture. So what may or may not get through the filters, UV can take care of. And so that's kind of what I see as the next value proposition moving forward into the IAQ 2021 and 2022. So thanks.
Gotcha. Jose?
Yeah, I agree with Keith. I think all the new technologies can complement to each other, and also right now there is a concern about the filter changing procedure, and if the virus is stuck in the media and so on. So I think UV can be an alternative and all other technology. So I think this merge of technologies will be the new trend.
Gotcha. Brad?
I think especially just speaking to the polar ionization, the plasma generators that are out there, I think we're going to see a rethinking of the technology. It's been around since 1870, but I think what the thing is they're going to have to, if they really wanted to see it be viable to support UVC, to support the other efforts, they're going to have to rethink their the way that they're sizing it. It's not being sized appropriately. These things are relatively inexpensive. They're not hard to install, but there's not enough of them being installed in the right places. So I think we're going to the guidelines change for the installation of them to make sure they're actually effective. It's really tough to put this thing in and the guy walks in a room and he doesn't see anything different. So, you know, where the other products, they do see a difference. So I think they're going to have to think about that.
So I'm going to keep going. A little bit overwhelming, by the way. I love it. We've got more questions coming in than we're ever going to get through, and we've got about 7 minutes left. This is great stuff. I'm going to ask a question because I think this one is a really important question. We've already halfway answered it. So if you've answered, you know, don't try not to dwell on or be specific. What is the most effective way to test and verify that the system you're talking about today was properly installed and specified? So how do we perform a field test to say it's working and we know it's going to give us the results that we expect? Keith.
Good question. There's two ways I need to answer this. So first and foremost, as specified for UV, not all engineers know enough about UV to properly specify them correctly. So testing as specified is a little more difficult because the engineer may or may not get it. Secondly, let's say he did, everything's good, system's installed. For UV, you have to have a method of capturing contaminants and culturing them or proving that they're viable or non-viable. Because with UV, we don't remove anything. We disinfect or smash the DNA and RNA. The contaminants may or may not live out the rest of their lifespan, but they can infect. So just doing a mold spore count, tells you nothing with UV. You have to find out if they're viable or viable. So you're going to have to search out a good lab that can perform that test properly. Thanks.
Thank you. Jose?
Yeah, I think for my technology is easier because we can measure particles inside the room. Of course, we cannot determine if it's viable or not, but we can measure considering a portable unit with a HEPA filter. So I don't see any problem. Of course, if you can explore more the system efficiency, you can generate artificial particles and measure, and then start run the product, the equipment, and then see the decay rate for that specific size of particle. But I would say a particle counting is enough to give you a rough idea of the performance.
Gotcha. Thank you. Thank you. And Brad?
I've had good luck with using ion. Obviously, we showed the ion count measuring devices that are out there. There's a number of good ones that are calibrated, and they're under $1,000. That's fantastic. Also, you can use DDC systems to do continuous monitoring. But I've had really good success with TO15 testing with both UVC and with the room ventilators as well. Just being able to measure the overall VOCs in a total measurement, and just surface testing as well. But I'm a little different. I actually do lab testing. I use 2 different laboratories in the Seattle area that are reputable for checking my stuff. And those technologies are proven out steady. And I think it is good that they do spot check, annually. That's kind of what I'm recommending, is you spot check, and if things come back good, then you're good.
Gotcha. Good. I think, so we've got about 3 minutes left. I'm going to ask just one more question, but it's a tough one. Jose, I know your technology can kind of combine everything, and Keith and Brad, you see your stuff in buildings with each other. Do you look at your product as a complementary product to each other? Kind of quickly, Keith.
Absolutely. All of these technologies can be complementary because as we mentioned earlier, filtration captures, depending on the size of the particle, UV kills, which is complementing to filtration, and bipolar can agglomerate, making those smaller particles larger, making them easier to capture in filtration and get them out of the breathing zone. Thanks.
Great answer. Thank you. Jose?
I agree. I think they are complementary.
Awesome. And Brad?
Yeah, I think the people who've tried to go it alone with just one have been disappointed. I think you have to go back to fundamentals. Fundamentally understand if your filtration system works, follow the NAFA guidelines. And if you do that, then you can use these others to bring up that confidence level based on the application of the facility. And if you do that, we really can win this war as long as the social engineering's in place.
All right. Well, we have reached 59 minutes on our presentation. Panelists, you guys were awesome today. Thank you very much. Again, it's an exciting time to be in filtration. We are indebted to you for the education you've provided us today. I appreciate NAFA going out and NAFA fulfilling its mission statement to educate us. And now it's up to us, right? It's up to us to get out there and provide the world a better indoor air quality experience. So thank you again, panelists. You guys have been fantastic. Each of you are experts in your field. There is a ton more questions. Tony, I'm probably going to be contacting you to figure out if there's a way to get some of these answered, because there are a lot more specific questions. Hopefully I gave everybody the appropriate amount of time. I do know, Tony, I'm not sure if you want to go a little bit further, but for everybody out there in NAFA world, I think there's 202 people left. Thanks for attending. Thanks for fulfilling our mission out there. And I believe NAFA is going to be promoting the next get together is going to be on public spaces and the travel industry and some of the development and filtration in that area, I believe. So we'd love to see everybody aboard for the next presentation. Thanks for coming.
For more information about how the National Air Filtration Association's membership, networking, education, and certifications can improve your career and business, visit nafahq.org.